The following animation demonstrates an application of PBMO in support of developing an optimal exit and site closure strategy at the former Fort Ord site in California. Notably, this is an HGL award-winning project. Operable Unit 1, or OU1, is located in the northernmost portion of former Fort Ord. OU1 comprises the contaminated groundwater plume emanating from a former fire drill area that operated from 1962 to 1985 for the Fort Ord Fire Department. As part of the training activities at the site, waste fuel was discharged from an on-site storage tank into a pit, ignited, and then extinguished. Other fuels used included hydraulic and lubrication oils, gasoline, diesel, and solvents. Training activities at the fire training area ceased in 1985. Trichloroethylene, or TCE, has been the primary chemical of concern since 2008. HGL began work at the site in 2003. At that time, 2 extraction wells have been installed near the source area. The data available at the time of HGL's performance-based remediation contract award showed the plume extent to be within the Fort Ord boundary. However, in 2005, HGL's field investigations showed the plume extended beyond the former Fort Ord boundary and into the adjacent private property used as a cattle pasture. Groundwater flow direction showed a plume migration path toward a neighboring residential area, as confirmed by subsequent Army investigation. In the northwest-southeast trending cross-section shown, the plume dips below the water table as it approaches the site boundary. The pre-2004 boundary monitoring wells failed to detect the fugitive plume. To overcome this problem, the groundwater pumping and treatment system within Fort Ord was expanded by HGL incrementally from a pilot system in 2006 to halt off-post plume migration to the final system in 2011. The Army remediated the off-post portion of the plume in 2008 to 2009 through a focused pump and treat system. To ensure that site closure was completed in the most cost-effective and timely manner, HGL undertook the following steps. HGL recalibrated the groundwater flow and transport model developed during the remedial design phase to simulate the migration of TCE and OU1 groundwater. Since 2008, TCE has been the only COC detected at concentrations greater than the aquifer cleanup levels. The recalibrated model was used in conjunction with HGL's Physics-Based Management Optimization, or PBMO tool, to evaluate alternative pumping strategies, including varied extraction rates, continual versus intermittent pumping at any combination of wells, and construction of new extraction wells in the remaining zones of contamination. The results of the PBMO simulations provided the basis for developing an optimized exit strategy to ensure that cleanup goals were met in the most cost-effective manner, while completing the remediation within the time period envisioned in the Record of Decision. A PBMO optimization analysis was initiated in concert with the subject matter expert to further optimize the system. PBMO's role was to evaluate pumping rates in remedy-in-place wells, and whether adding additional wells would improve remedy performance. The objective of the optimization was to minimize either remediation time or cost. The Site Record of Decision projected a 30-year groundwater extraction timetable with remediation complete by the year 2018. In all, there were over 100 decision variables and over 50,000 constraints. The optimal solution was identified as the least cost solution that did not violate any of these constraints. PBMO rejected all solutions that included adding new extraction wells from a cost perspective, and also optimized, reduced the total extraction flow rates, and redistributed the well pumping rates in each of the 8 wells to optimize this system. Results are summarized in this slide. The upper left-hand frame shows that the operation and maintenance cost were reduced by PBMO from $661,502, which was based on the remedy-in-place pumping and injection schedule, input from the subject matter experts, to $172,121, or close to $500,000 in cost savings. Stack plots in the top right-hand frame show comparisons between the remedy-in-place and PBMO optimized costs and pumping rates. The total pumping rate was reduced from 56.5 GPM to 10.7 GPM, or a factor of 5. Bar plots in the bottom right-hand frame show comparisons between remedy in place and PBMO optimized individual cost components and well pumping rates. A comparison between maximum TCE concentrations over time due to the remedy in place and PBMO optimized pumping schemes in the bottom left-hand frame shows that the plume was actually projected to remediate slightly faster using these lower, optimally distributed flow rates. PBMO was successful in developing an optimized pumping strategy for the former Fort Ord site. The remediation activity planning was accepted, and completion concurrence has been approved by state and federal regulators. HGL has also received a letter of commendation from state regulators for quality performance. In a nationwide competition, this former Fort Ord performance-based remediation project won the 2017 Grand Prize Award for innovative project implementation to overcome unexpected challenges and complexities. This prestigious award was bestowed upon Hydrogeologic by the American Academy of Environmental Engineers and Scientists.